Warm greetings to one and all. Today's session is all about development and programming of animatronic hand, a joint initiative by faculty and students of Department of Mechatronics Engineering, Satyabama Institute of Science and Technology, Chennai. Topics covered in this session are overview of an animatronic hand, working of an animatronic hand, parts needed for developing an animatronic hand, fabrication and assembly of an animatronic hand, coding used for animatronic hand, applications of animatronic hand. The students who are involved in this content development are Solomon Arokiraj, Anirudh, Prasanna Kumar, Sudarshan, Rohit, Siddharth and Mukhilan. Hope you watch and enjoy this session. Your appreciation and feedback are most welcome. Kindly post your queries and feedback on the chat box below. Thank you.
For the people who are not familiar with robotics or electronics, don't worry guys, we will be starting this session from the scratch with basics. Let's move on to the intro.
What exactly is animatronics? Animatronics is an interesting technology used to create robotic systems that seem animate. The examples of animatronics include robotic animals and humanoids. It is largely used in the entertainment industries for making movies, theme parks. It is predominant in industries nowadays for its ability to carry, move, or transfer delicate objects from one place to another. The word animatronics is actually a combination of three words, technically three fields: animation, electronics, and robotics. We all know that animatronics is usually used to control humanoid robots. Taking one step further, it is also used to control minute expressions given by humanoid robots. Origin of animatronics. The first ever application of an animatronic technology dates back to 1964, and Walt Disney Productions takes the credit of creating the first ever humanoid structure. The first ever animatronic structure created was that of Abraham Lincoln. This was reportedly an awe moment for all the people who witnessed the magical sight. The movement and reactions can be set externally, and the technology exhibits as per the movements that are programmed. What is animatronic hand? Hand is a design of the robotic hand that works under the information that are received from a structure called flex sensor, which is most often used in the animatronic hand projects. Speaking briefly about the working of an animatronic hand, the flex sensor senses the movement of the glove hand or the glove sensors and replicate the movements in a robotic hand created. Technical aspect: the user wears a control glove and can control the animatronic hand precisely. So, we are using some sensors for this process to happen. Those are called flex sensor. Depending upon the bending of the flex, this resistance will increase so that the servo motor will do the appropriate action. We will dive deep into these terms and topics in the later part of the video. Applications of animatronic hands. The animatronic hands have efficiently helped physically challenged people lead an ordinary life. Physically challenged people use it as an extra alternative hand. Two hands for the same operation can be utilized with this animatronic hand.
Let us see briefly how animatronic hand works and what are the components we require to make an animatronic hand. Now you can visualize a flowchart of how animatronic hand works. Here sensor, that is flex sensor, acts as an input device that gives a necessary input based on the way how you flex or bend your fingers. Here, microcontroller, that is Arduino Uno, that interface the animatronic hand, assesses the signal from the sensor and executes function based on the preloaded program. The actuators, that is servo motor, acts as an output device that executes the action based upon the signal received from the microcontroller device. So in this video we can see the working of animatronic hand. The flex sensor integrated to the gloves gives an input to the Arduino board in the basis of how you bend the hand, and the Arduino board assesses the signal from sensor and executes the action based upon the preloaded program. Here the servo motors connected to the Arduino board using PWM pins gives an output that received from the Arduino board, so that the animatronic hand starts to bend according to the servo motors rotate. Let me show you what are the components we require to fabricate an animatronic hand and flex sensor. For flex sensor we require insulation tape, single core wire, conduction foam, aluminum foil and wire stripper. For animatronic hand we require Arduino Uno, servo motors 3, breadboard, coroplast board, gloves, threads, rubber bands, cutter, nuts, feviquick, jumper wires, resistor, type B cable. Let us see a detailed explanation on some above mentioned components.
Arduino Uno. An introduction. Arduino Uno is technically defined as an open source microcontroller housing in a microchip termed Atmega 328. Arduino boards form the basic foundation of an entire robotic body, like the one we are going to make now. Arduino boards, in other words, is essentially the heart of an entire system. An ideal Arduino board is equipped by a set of digital and analog pins. There are 14 digital pins and 6 analog pins. Out of these 14 digital pins, 6 of them are known as PWM pins, which are otherwise called as pulse width modulation output pins. What makes these pins different from all the other digital pins? A PWM pin generates an analog signal using a digital source, which can be put in other words as an analog output is obtained using digital means. Programming an Arduino Uno can easily be done using a Type B USB drive, which is connected to the built-in USB jack present inside an Arduino Uno. The USB cable is connected to the compiler, where the program is typed out and the functions are transferred into the Arduino Uno in order to perform various important functions and movements. The most well-known way for powering an Arduino Uno is using a 9-volt battery. Although an Arduino Uno can be powered in a wide range of voltage ranging from 7 volt to 20 volt, a 9 volt battery is most often used in order to power an Arduino Uno.
When it comes to motor-driven application in a project, selecting the best suitable motor for the given task in a project is important. There are 3 different types of motors. brushless DC motors, stepper motors, and servo motors. When it comes to positioning tasks in a project, a stepper motor is usually a safe bet, but servo motors combine the motor with control electronics to achieve maximum accuracy. I'll show you how such servo works and how you can easily use one in your projects with a microcontroller. The most common servos all look very similar. All have a sawtooth shaft on top in order to attach different kind of accessories necessary for your project, and three wires coming out of them. Brown is ground, red is VCC, which usually requires a voltage of 4.8 to 7.2 volts, and orange is the input pin for the control signal. The control signal is usually a PWM signal. So why are we using PWM signal instead of digital signal? Digital signal is a continuous stream of on and off signal in regular intervals, which takes much time to interpret. Whereas PWM signal is a single change in voltage signal, which is interpreted by the duration of the single signal, thereby reducing the time lag in between the command. These PWM signals have period time of 20 milliseconds and a duty cycle of 1 to 2 milliseconds, where 1 millisecond represents minus 90 degrees and 2 milliseconds represents plus 90 degrees. The intermediate time represents the intermediate angles, like 1.5 millisecond signal for 0 degrees. Within a servo motor, you can find 4 different sized gears that decreases the original RPM of the motor, also increases the torque. Underneath one of the gears of the shaft, there is a potentiometer. It acts as an feedback for the control integrated circuit. This IC constantly compares the potentiometer voltage, aka the current state, to the intended position of the PWM signal, aka the target state, and then lets the motor rotate in either direction to achieve maximum accuracy. And that is basically how a common servo motor works. Let me show you how to connect the servo motor to Arduino Uno. A red pin of the servo is connected to the 5V pin in Arduino. The brown pin is connected to the ground pin using male-to-male jumper cables, and the orange pin to the one of the PWM signals out pin, usually 3, 5, 6, 9, 10 and 11. Make sure you are connected to the right pin that you assigned in the code.
Flex sensors. We will be using sensors as our input devices in this project. The sensors we will be using are called flex sensors. Flex sensor is a passive resistive device used to detect the bending or flexing. When the resistor is flexed, the resistance across the sensor changes, and the amount of bending can be determined by comparing the change in resistance. The most important component in a flex sensor is resistive material. We'll be using a conductive foam and aluminum foil on either side, which conducts current when voltage is applied. This sandwich is insulated and terminal wires are connected to the circuit. The conductive foam is a plastic foam with carbon particles. Its conductivity increases as the foam is compressed, thereby reducing the resistance in the sensor. The change in resistance due to the flexing of the sensor is recorded by connecting the flex sensor to a voltage divider circuit. A voltage divider is a simple circuit that converts large voltage to smaller voltage. The simplest voltage divider is a circuit with two resistors connected in series, as shown here. A voltage divider is necessary because the change in resistance in a circuit can be easily converted to change in voltage. This is essential because microcontrollers can detect change in voltage easily than change in resistance. So flex sensors are connected to microcontrollers through a voltage divider.
I think you have learned some basics about components in the previous part. Now we are moving on to the fabrication part.
Hey guys, I'll quickly summarize the things we need to make this fabrication. And the first thing is the foam material, and we use this material to make our hand, animatronic hand. And the second thing is our Arduino and some threads, nuts and rubber band and some multiple wires and a breadboard and a knife. And this is our gloves in this project, and this is carbon material conductive foam, and we are going to make the flex sensor using these two, and this is aluminum foil. We are going to make the flex sensor using these materials, and this is our servo motors, and this is some of the arms and screws, and we have one wire cutter, and we are going to make the fabrication. Let's see how to make our own flex sensor. Take two pieces of single core wire of length 10 cm. Remove the plastic insulation around the wire. Now we need two pieces of single core wires without plastic. Make a conductive foam with dimensions 10 into 1 into 1. Now cut two aluminum foils with little lesser in dimensions to the foam. Use your duct tape with 2 cm in breadth or overlay one another like we did here. Place the wire in the middle with some extending wires. Place the foil over the wire. Make sure that the wire is in contact with the foil. Similarly, make another setup and sandwich the conductive foam in between. Make sure that your wires are extended outside. Make sure that neither part of the foil are making contact with one another. Now we have made our flex sensors with two terminals. Cut the extra tapes which are extended outside. One side of the wire should be connected in the analog pin of the Arduino and another side should be connected in the 5V pin of the Arduino. Similarly, make two flex sensors for our project. Now, take the wire and separate these wires in a pairs. I made blue and violet as a pair, and yellow and green as a pair, and red and orange as a pair. Now connect each terminal to a wire and cover with the insulation tape. Make sure none of the terminals are left uninsulated. Now take other side of the wire and connect 6 male header wires and cut them into two and strip their ends. And then insulate each joint of the wire with the insulation tape. Now we connected our 6 male jumper wires to the flex sensors. For checking whether the flex sensor is working or not, take a breadboard and an Arduino. Connect one terminal of the flex sensor to the 5V of the Arduino and another to the A0 pin of the Arduino. You can just directly connect to the Arduino or just use a breadboard. Now we should upload our code for checking whether flex sensor is working or not. Now I uploaded the code in my Arduino and we are going to test this flex sensor is working or not. See, while I am not bending, the flex sensor analog readings are 1023 and above. While I am bending, the readings coming below 1000 and it reaches 994 and 990 is below. This concludes that when I bend the flex sensor, the value is coming below 900. When I am not bending it, the value comes above 1000. This shows that this flex sensor is perfectly working for our project. Just check another two flex sensors is working or not. Now I check the flex sensor. This flex sensor is not working at all. When I bend it, its value is not decreasing from 1000. So we should make another flex sensor and replace that flex sensor in the same place. Now take three flex sensors which are perfectly working and connect them to the gloves on three fingers: thumb, index and ring finger.
Instead of using this material, we are going to show you a rough sketch on A4 sheet. Make an outline of your hand and cut it. Now similarly, cut the outline shape on coroplast material. Use one half of the material since we will need other half to make a base for mounting motors. This is how it looks. We have flexion creases on our fingers, each representing a joint. We are going to partially cut the material at these joints, which makes it easier to bend. Remember, the material we are using is two-layered, so a cut in single layer can give required flexibility. Take the material and slice some cubes and cuboids. We will be using these to run our thread and rubber bands. We will be needing 32 pieces of cubes, 4 cuboids and 1 piece of the multiple holes. Take some rubber band, fix them on the hand model as shown here using Fevikwik. Cut the rubber bands and tie one of the band to the end of the finger and other to the palm by running them along those tubes. Similarly, tie rubber bands to other fingers. Make a base out of the material as shown here and fix it to the hand model using Fevikwik.
Here an example drawing of this base from CAD.
And cut 3 holes between to mount servo motors. Take 5 pieces of thread and tie one end of them to a nut. Pass each thread through those tubes and tie the thread on one end of the finger. And that's how it should work. Similarly, tie threads on all fingers. We will be using single servo motor to control index and middle finger. So we are going to tie those two threads together. Similarly, tie ring finger and pinky together.
Servo motor and armature setup. Before getting into the fabrication part, we need to zero set our servo motors and position our armatures. Here is how our armature looks like. We know that a servo motor can only rotate in 180 degree. We can set the servo motors to 0 and reposition our armature to the angle of rotation we want to achieve. Let us see how to make this setup. First, we need to know about the breadboards. Breadboards are usually used in prototyping electronic circuits. Breadboard does not require soldering. It is reusable. This makes it easy to use for creating temporary prototype and experimenting with circuit designs. Breadboards are connected pin to pin by metal strips inside the breadboard. The layout of a typical breadboard is made up by two types of areas called strips: terminal strips for electronic components and bus strip for power supply. Connect the VCC and ground pin on the servo motor to the breadboard's power rails. Now connect the signal pin on the servo motors to 9, 10 and 11 pins on Arduino Uno. The order of the arrangement does not matter, since we will be giving the same command to all the motors. Using the jumper cables, connect the ground on the Arduino to the ground rail on the breadboard and 5V to the power supply rail. Let's see how to write a program for Arduino Uno to execute this command using Arduino IDE, which is free software available on Arduino website.
Welcome to the segment where we will see about the zero setting of the servo motors. First, we will start our program by adding servo data chatter file, which helps us to use predefined servo functions and also to help Arduino board to control servo motors. Then we will declare variables servo 1, servo 2 and servo 3 for each servo. After this, we write setup method, that is void setup. Void setup is used to initialize the variable and set up the position of the servo. Under the setup method, servo.attach function is declared to attach the servo variables to the pins which is in Arduino. Here, the servo 1 variable will be attached to the pin number 9 in the Arduino. Likewise, the servo 2 will be attached to the pin number 10 and servo 3 will be attached to the pin number 11 in the Arduino. Then, using servo.write, we write a value to the servo, controlling the shaft accordingly. Here, we declare the initial servo angle for each servo as 0 degree.
Now our motors are at their zero position. For this project we need a rotation of 90 degrees to 270 degrees. Therefore we are repositioning our armatures accordingly.
Take 3 zero-setted motors and tie those threads to the arm of the motor. Put the arm on the motor at 0 degree. Screw the arm to motor. Mount the motors as shown.
Wiring the components to Arduino Uno. Now I will show you how to connect Arduino Uno to the flex sensor and servo motors, which will be controlling our animatronics hand model. Here's a simplified schematic of our circuit. First, make sure that there is no metal objects under as well as close to the controller. Obviously, because we don't want to short circuit our processor. Connect the either ends of the power rail on the breadboard. This gives us a flexibility in placing the components on the breadboard. Take a 10 kilo ohm resistor and hook one end to a power supply and other to one of the columns as shown here. Make sure you have 2 pins in the same column. Connect 2 more resistors in the same way. Each flex sensor has 2 terminals. Connect one to the ground and other to one of the columns we have connected our resistors to. Connect these terminals in a way such that one pin is empty in between the terminal pin and the resistor. Connect analog pin A0 on Arduino Uno to the open pin in between the resistor and one terminal of the flex sensor. Similarly, connect analog pin A1 to the flex sensor of index finger and A2 to the flex sensor of ring finger. With flex sensor connected to the Arduino, let's connect the servo motors. The VCC and the ground of the motors are connected to the power and ground pins on the breadboard. Signal pin is connected to the Arduino in the following order. Servo for thumb action to pin 9, servo for index and middle finger action to pin 10, servo for ring finger and pinky action to pin 11. With that, let's connect our power and ground supply. Ground on Arduino board is connected to the ground on a breadboard and 5 volt is connected to the power supply rail on the breadboard using jumper cables.
In this segment, you will learn to code for your animatronic hand. First, we will start a program by adding servo.h header file, which helps us to use predefined servo functions and also to help Arduino board to control servo motors. Then, we will declare variables servo1, servo2 and servo3 for each servo.
Next, we declare three variables, val1, val2 and val3. These three variables are used to get input values in analog type from pins A0, A1 and A2. After this, we write setup method, that is void setup. Void setup is used to initialize the variable and set up the position of the servo. Under the setup method, servo.attach function is declared to attach the servo variables to the pins which is in Arduino. Here, the servo1 variable will be attached to the pin number 9 in the Arduino. Likewise, the servo2 will be attached to the pin number 10 and servo3 will be attached to the pin number 11. Next, we assign the initial position of all the servos as 0 degree. And then we set the baud rate for serial communication as 9600. The baud rate is the rate at which information is transferred in a communication channel. The possible baud rates are 300, 600, 900 to 1,15,200. 9600 baud means that the serial port is capable of transferring a maximum of 9600 bits per second. After creating a setup function which initializes and sets the initial value, the loop function is created. Under void loop, the instructions which are supposed to be executed repeatedly is returned. We know that when you bend the flex sensor which is attached to your finger, the change in resistance reduces the output of the voltage in the voltage divider circuit, and that reduced value is sent as the input to the Arduino. Moving on, the analog read command reads the value from the specified analog pin and converts the input voltage range to a digital value. Here, the variable val1 will store the input of the voltage at pin 0. Thus, val1 is equal to analog read A0 is declared. Likewise, the variable val2 will store the input of the voltage at pin A1, and the variable val3 will store the input of the voltage at pin A2. Then, using serial.println, we can print data to the serial port as human readable ASCII text. Here, this is used to get the data from the variable val1, val2 and val3 and display it on the screen. To get the information from val2 and val3, /t is used. The /t is called escape sequence, which represents the tab character. It is used when you want to put information in columns. As I have mentioned before, when the flex sensor which is attached to your hands are bent, the resistance which will be sent as the input to the Arduino will be reduced to less than 950. And when it's not bent, the resistance sent as the input will be greater than 950. This is the main logic of the program. So, if you bend the finger, the input from the pin A0 which is assigned to the variable val1 will be less than 950. Hence, the servo motor 1 which is connected to the pin 9 will rotate 180 degree. If the flex sensor attached to a hand is unbent, the input which is sent to the Arduino will be greater than 950. So, the servo motor angle will be at 0 degree again. Similarly, for the other two servo motors, the program should be written on the same logic as previous using val2 and val3. For valve 2, the resistance will be less than 1000 if it's bent and greater than 1000 when it's not bent. For valve 3, the resistance will be less than 990 if it's bent and greater than 990 when it's not bent.
Okay, there is a problem in using these types of flex sensors. These types of flex sensors will not give an accurate value for your project. If you want your project to look more good and to work more accurately, the only way is to buy the flex sensor in online or market. See, when I flex this finger, these two fingers will work. When I relax, it will be relaxed. When I flex this finger, these two fingers will work. When I relax, it will be relaxed. When I flex this finger, it will work. When I relax, it will be relaxed. So these types of flex sensor, you should give a little bit of pressure inside your hand or fingers. Okay, you should give some pressure in this finger so that it will give an accurate value in your program.
I hope everyone have gained some knowledge in developing an animatronic hand. Now let us see where these animatronic hands are used. Animatronic hand plays a vital role in industries and research development science, dealing with radioactive and chemical materials so that the skin diseases can be avoided for those workers. They are also used in theme parks to make robots resembling living creatures and puppetry. International space stations uses them to perform difficult maneuver in outer space while reducing the risk and necessity of an operator. These hands can be powerful aid for physically challenged people.
On behalf of the Department of Mechatronics Engineering, Satyabama Institute of Science and Technology, we register our sincere thanks and gratitude to our management for their constant motivation and support. Compliments to Anirudh and Prasanna for their wonderful coordination and participation in video graphics and animation. Special note of thanks to Mugilan and Sudarshan for coding and also to Rohit for the entire video scripting. We also appreciate Siddhartha for his contribution in CAD design. And we congratulate Solomon for coordinating the complete video tutorial. Thanks for watching.